it is can be neglected. Why? Because the time t equal to 0 only. It does not require any time to perform this operation. Whether it is 0 or not, it is not giving any carry. Why? Good evening, all. Good evening, people. Rahul, Aishwarya, Dhanpal, Sumit, Abhinit. Good evening, Vivek. I'm fine. Plus Sushil, Nishita, Shivam. Good evening. Nice. Good evening, all. Aduri, Chaitanya, Ravi, Pranal, Arun, Udik. Good evening. Someone, Chaitanya. You got 15 problem. Very good. Subha Sanjaya. Namaste. Good evening. Okay. All problems means which problems? Namaste. Good evening. Sushil, today's class will be problems only and your doubts only. Nothing more than that. Nothing new will be discussed. That is for sure. But we'll do some interesting questions. Robert, namaste. So, what is the plan? I will try to conduct some kind of quiz here. Your doubts, maybe some kind of fast quiz. Okay. Quiz means like a poll. Okay, nothing different. But you will end of the day you will be knowing how many questions you are able to answer. That will. So only problems only we'll be doing. So let's start with the first homework part. So homework. One minute. Let me download the slides. Right, done. Good evening, Ganesh. So I hope not passed by, not typing anything. So right, let's do that 50 nanoseconds, whatever that question is there. I hope some people are done, but still listen how we need to do that. Let me upload the question. Where is that question? So some of you might got the answer already, but let's see how to do it. Whether your approach is correct or not, you will be able to understand. Answer may be correct, approach is correct or not, you will be able to understand. So this is the question I have given as the homework day before yesterday. So some people got the answer rightly, remaining people whether you got the right answer or not, let us check it. Okay, how to do it? Let's check it. So please understand here the question is 4-bit triple carry adder realized using full adders. The figure 2 shows the circuit of full adder. So this is the full adder. Okay. Namaskaram, Edi. It is like AX or B, X or Y, Z, A, B, C, whatever may be the variables, doesn't matter. It is AX or B. What is this? Sum AX or VX or C. You know this already. What about this one? It is A into B AND gate now, plus this one. This is your C. This is your A XOR B. So you can say A XOR B into C. And this one is AB. So what is the answer? AB plus A XOR B into C. That is your carry. Okay, I told carry can be implemented by two different ways. I show you already same things. The same question is given here. Examiner has given that its delay is 20 nanosecond. Its delay is 20 nanoseconds. This one is 15 nanoseconds, 15 nanoseconds, and 10 nanoseconds. So what is the question is simply you want to perform the operation of 1100 plus 0100 addition with carry input equal to 1. Okay, is asking simply what is the answer. I mean, not what is the answer. What is the delay, total delay for this operation? Please read this. The output will be stable at what time? The question is the output of the carry adder is stable at what time? At what time it will be stable? Stable means it is not changing further. Okay, so let's do it. I will do this question by two methods. First method is the first method is take the input. Then 0 1 0 0 and what is the carry? 1. Two methods, please observe carefully. Any method, whichever you feel comfortable, you will use that method. Okay, you can follow that method. If you feel this is complex, we go by another method also. So add these two, three. Firstly, what is the answer? Sum is 1, no carry, sum 0, carry 1. Okay, and finally sum 0, carry 1. Okay, now please understand carefully what is the time required to perform this operation. 0 plus 0 equal to 0 is already, answer is already at 0. So it is can be neglected. Why? Because the time t equal to 0 only. It does not require any time to perform this operation. Whether it is 0 or not, it is not giving any carry, it is not giving any sum, it is not doing any addition also, it will not require any time. Okay, and you understand here, this addition is giving some carry to this. Okay, so these two are dependent on other. That is, the last addition is depending on the first addition. I mean, this addition. The last addition is depending on this addition. Yes or no? What about this one? What about this one? It is independent addition. So what does it mean? You analyze this. Okay, this, and also analyze this. Okay, so if you take this as a T1 and this one is TD2, what is the delay is equal to maximum of TD1 and TD2. Can I say like this? Accepted or not? Tell me. I'm just giving you process. I have not started the problem at just I'm giving you the process to start the problem. Okay, if you do this addition is not giving any carry, so this addition is not giving any carry, they are independent of each other, and then this addition gives carry, so they are dependent on each other, then you will get the result. So these two I analyze together, this I analyze individually, calculate the time for this part and this part, whichever takes more, that is the answer. Any doubt, please ask now itself, because If you don't understand this, you cannot understand the next step. That's why. So if everybody is clear, we will move to the next one. Next is, so I will keep its name as full adder 0, full adder 1, full adder 2, and full adder 3. Okay, so let me start with full adder 1. Not 1, 0. For full adder 0, A, B, and the carry input. What is A? Tell me here. A is 0, B is 0, carry input is 1. According to question, please understand that. According to question, Z0 is your carry. Okay. Yeah, I'm assuming this as A or B. X or Y, your wish. Nothing wrong. You want X and Y, take it. This is X0, Y0, and Z0. Okay, all of them applied at what time? Time t equal to 0, ready. Now these two are given to XOR operation. X XOR with Y. What is X XOR with Y? Tell me. Already it is at 0. Now also 0. It does not require any time. You understand this point or not? Already it is at 0, na? So after giving the input also it is changing 0. It does not require any time to change. But now see, this 1 will come, then X XOR Y XOR Z. What is the answer? This is 0 XOR with 1, which will give you 1. Now this process requires how much time? 20 nanoseconds. So at time t equal to 20 nanoseconds, you will get this. This point is clear for everybody. This time is not, every XOR operation requires 20 nanoseconds according to the figure given by examiner. This also 20, this also 20. But then the answer is 40, sir. No. Worst case, it is 40. But in this case, because these are 0, 0, this gate will not take any time because it is already at 0. Now you applied this input, immediately 0 and 1 will give you 1. You understand this concept or not? It does not require any analysis here. That is your sum. Okay. So if you want, you can analyze the carry, but I already told you no carry is there. What about carry? Not required. I am doing this for your satisfaction. What is carry? X. Oh, yeah. 1 minute. One minute. Okay. So for carry, what to do? For carry, what to do? It is actually not required, but X naught, Y naught plus X naught XOR with Y naught plus Z naught. You know it is 0 into 0, 0 XOR with 0 into 1, which is 0. Okay, it is not changing. 0 is changing to another 0. Initially it is 0, it is changing to 0. No need to do this analysis. It will not require any time for us. Everybody happy with this full adder 1 analysis or not? I'm going step by step. That's why it is taking more time. Okay, so that everybody able to understand. So now come to the main part. Full adder 1 you need not analyze. Full adder 2 and full adder 3. These are important. So be careful. Please concentrate. So x1, y1 and z1. What are they? 1, 1, 0. 1, 1, 0. What is your sum? For sum, what is 1 XOR with 1? Okay, x1 XOR with y1 equal to 0. Then, now again, this 0 will come. So, x1 XOR with y1 XOR with z1. This is also equal to 0. 0 XOR with 0. So, this not require any time. Why I took 0 nanoseconds? Because already it is at 0 only. It is changing to 0. You need not worry about this time. Is this point clear for everybody or not? Tell me. Okay. Now here, important part is carry. Please concentrate here. X1, Y1, Z1. Now 1 and 1, this is 0. So for carry, what is your formula is XY plus X XOR Y into Z. You remember this? So XY, what is this? 1. But X into Y and the gate requires how much delay, man? Tell me please, comment. Yes, 15 nanoseconds plus X XOR Y. What is X XOR Y? 0 into 0. Okay. So 0 into 0 will give you 0. But please understand 1 plus any. 1 plus any. What is the answer? 1 plus any is equal to 1. For our operation, 1 plus any is equal to 1. If this 1 is present at 15 nanoseconds, OR gate requires another 10 seconds. So total how much? 15 plus 10. 25 nanoseconds. Samira, please understand, it is already at 0. Please listen. Your gate is like this, 0. Now it is like this, for example. Now you applied 1, 1. What happens? This 1, 1 will give you another 0. It does not changing now. So you need not worry about time. It is already stable. You understand? You have applied this, it is already at 0. After applying also it is 0, not changing in between. Then you need not worry about how much time it took. It may take 20 seconds or 10 seconds to get this 0, but it is of no use for us. OR gate. OR operation requires 10 nanoseconds according to question. AND operation requires 15. OR operation requires 10 according to the statement of the question. So when you apply dot operation, take 15 nanoseconds. When you apply OR operation, take 10 nanoseconds. Yes, Sudit, in between also, you can say not changing at any point. I am not saying this kind of hazard condition. I am saying when it is not changing any time, no need to worry about it. Okay, fine. So shall I proceed further? Okay. So up to this is fine. Last stage we are moving. Full adder 3. Okay. Now what is x3 is 1. What is y3 is 0. What is z3? It is 0 initially. It is 0 initially. Now for sum, now carefully observe one thing. What is 1 XOR with 0? It will give you 1 at 20 nanoseconds. Okay. Then what is 1 XOR with this one? What is 1 XOR with 0? It is at 20. It is another 20. 20 plus 20. It will give you 1 at what time? 40 nanoseconds. Okay. But here carefully observe one thing. This is 0 initially, but this Z3 is, what is Z3? Coming from here. Z3 is coming from here. What is Z3? Carry here. What is the carry here? Is 1. That will come at what time? 25 nanoseconds. So at 25 nanoseconds, what happens? You understand this 0 is changed to 1. At what time? 25 nanoseconds. Then this, what is the answer now for this one? When this 0 is changed to 1, then it will change 1 XOR with 1, which is equal to 0. So at what time you applied this input? 25 plus 20. What is the answer? 45 nanoseconds. You observe here, you understand this properly. Please listen. It is initially your sum is equal to like this. Initially 0. Okay. I'm saying final output, not in between. I'm saying total x XOR y XOR z. I'm saying it will become 1 and again 0. At what time it is 1? 40 it becomes 1. At 45 it becomes 0. In this case, you observe, even it is changing from 0 to again 0 also, I consider this. I don't know how many of you while doing the problem have considered this. Even you don't consider also, luckily in this question you may get the answer. It may not be true every time. It may not be true every time, but this question, even you neglect this also, you will get the answer luckily. But please understand, you should remember and consider this when you do the problem. I'm repeating this analysis again. Please listen here. Yeah. I'm repeating the analysis here. Please see. First, these three are applied at time t equal to 0. So first to do this XOR operation, 1 will come at 20 nanoseconds. Everybody carefully observe. Nothing difficult here. 20 nanoseconds, I will be getting 1. Then this 1 is XOR with this 0. Okay, at 20 you applied this now. Another 20 you add 40 nanoseconds. You will get 1 as the final answer of what is this? X XOR Y XOR Z. But you have applied carry due to the previous addition at what time? 25 nanoseconds. So at 20 this operation is performed, you got answer, but 25 your input is changed. Your input is changed. Instead of 0, Z3 is made equal to 1. Now 1 XOR with 1 will give you 0 in the steady state, which will occur at 45 nanoseconds. This is intermediate. Up to carry is applied, this is the answer. Once your carry is applied, after 25 plus another 20, you get the final stable answer. Is it clear? For 100, what is X XOR Y XOR Z? It is 1. For 101, what is X XOR Y XOR Z? It is 0. So this is at 40 nanoseconds, but this will occur at 45 nanoseconds. Everybody understand? If you don't understand, please ask me. I'm happy to help you. Because this fellow comes at a time t equal to 25. Up to 25, same. Okay. If suppose this fellow comes at 15 itself, then by the time of 20 already your input may be ready. It depends on the question. Anyone having doubt, please ask. At 25th nanoseconds, what should become 0? At 25, you are giving 1, not 0. Yes, correct, AD. Samira, please see. It is 0 initially. Okay, at 25, you are giving 1. Once you give 1 to the XOR gate, it requires how much time? Another 20 nanoseconds. So you give it 25, but you will get it the result at 45. This will raise to 1 at 25, but the output will raise at 45. Okay. So let's move further. Lastly, carry. Okay. For carry, what to do? X3, Y3, Z3. Initially, this is 0. This is also 0. This is 1. Okay. So what is your carry formula? X into Y plus X XOR Y into Z. Apply this formula. What is X into Y? 1 into 0 is 0. Already it is at 0 only. Plus 1 XOR X XOR Y. What is this? 1 into 0. This fellow will come at what time? 20 nanoseconds. Okay. So 1 into 0 is anyway, it is 0 only. No need to worry about it. But at a time t equal to 25, this becomes 1. So what I can say is, otherwise I will use another color for you. Up to this clear now, everybody? Initially, these are the value. Further, so this is the answer. Okay. But at the time t equal to 25, you have applied carry. Then this part will change from 10 to 11. At what time? T equal to 25. Okay. 1 into 1, how much? 1. Okay. So it requires how much time to do the end operation? 15 nanoseconds. So 25 plus 15, at what time you will get this value? T equal to 40 nanoseconds. So OR gate is 0 plus 1 equal to 1. So OR gate requires another 10 nanoseconds. 40 plus 10, what is the answer? You get 15 nanoseconds. I'm repeating this part again for you. Please listen carefully. So listen here. This part x3 into y3 is 0, x XOR y is 1, which will come at 20, but into 0 is always 0. So no need to worry about this. At 25 nanoseconds, this fellow 1 will come. Now 1 into, okay, this is already 1 at 20. Okay, this will come at 25. You should take maximum of 2. Both are ready at 25. Then 1 into 1 will give you 1. At what time you get that? 25 you applied the inputs and gate require 15, so 40 you get this output. Now this is given to OR gate. What is the OR gate output? 0 plus 1 will be equal to 1. Okay, please understand, OR gate output will be equal to 0 plus 1, which is equal to 1. OR gate requires 10 extra, so 40 plus 10, 50. So everybody understand, the answer is 15 nanoseconds. Let's do by another method. Yes, Aditya. So please see, step by step analysis you can do like this also. Okay, initially full adder 2, that is x naught, y naught and z naught. Your x naught is 0, y naught is 0, z naught is 1. These are applied at what time? Time t equal to 0. Already all gates are at 0. Already all gates outputs are at 0 is the condition given by examiner. From the figure also you can analyze it. See how to analyze it. 0 XOR with 0 is how much? 0. If it is not changing, don't worry about it. Then here what is the answer? 1. 0 XOR with 1. What is the answer? 0 XOR with 1 will give you 1. At what time you get this man? 20 nanoseconds. Next. 0 into 0 is 0. This 0 will come here. Then 1 into 0 is 0. 0 plus 0 is 0. Carry is not affecting at all. So first sum is taking how much time? 20 nanoseconds. Like this also you can say. Is this point clear for one adder? Next. Full adder 2 is like this. X2, Y2, Z2. It is 0. What is your X2? 1. Y2 is 1. All are initially at zeros. Which color and where? It is impossible to understand if I explain here with the different color. I will show you how it looks. Okay. Then again. Now again I use same. Okay. Later when you see this slide, how you understand which full adder it is. I mean, when you download the PDF also, you should be able to understand. Na? In that case, I can use this figure itself. I do this story here itself. I will do. Okay. So listen here. Full adder 2, I have applied like this. Now you see 1 XOR with 1 is 0. No need to worry about it. 0 XOR with 0 is 0. No need to worry about it. Very simple. Now 1 into 1. What is the answer? This requires how much time according to the given question? It is 15 nanoseconds is the time it requires. Okay, this part is done. 1 comes here. 1 plus anything, 1 plus anything at 15 nanoseconds, you apply 1. 1 plus anything, what is the answer? 1. Okay, so this will become 1 at 15 plus 10. How much? 25 nanoseconds. So clear? Up to this full adder 2, it is 25 nanoseconds. This is what we give it as a Z3, that is a carry. Up to this clear? Last analysis, that is a full adder 3. So initially assume everybody is 0. This is your Z3, Y3, X3. Okay. So now listen here. This fellow is a 0, 1, 0, and this fellow is also 0. Z3 is 1 at what time? 25 nanoseconds. We are speaking at a time t equal to 0. Initially, we are speaking. We should go to 25 from 0 only. Yes. So start the analysis. So 1 XOR 0 will give me 1 here. At what time? T equal to 20. Your hero, your carry will come at 25 to save you. Okay. Hero not entered here. At 20, this fellow came 1. So here 1 will come at 20. And by that time, what is this value? By the time t equal to 20, this carry not change. Now, what is this value? 0 only. 1 XOR 0 will give you how much? 1. At what time? 40 nanoseconds. So still 1 into 0 is 0 only, and you will get 0 only. And this is also, this part is not changed. Up to this clear? Now your friend enters, that is carry, at what time? At t equal to 25. This Z3 has become 1. Okay, now this fellow has become 1. Now this 1 will come here. This fellow will become 1. At what time? 25. At 25 you applied 25 plus this fellow requires 20. 25 plus 20. What time you will get this? 1 and 1 will give you 0. At what time? 45 nanoseconds. This is what we call static zero hazard. Okay. Now come to this friend. Now this fellow is 1. 25 mein this fellow is 1. 1 into 1 how much? 1 into 1 how much? 1. So 25 plus this fellow will take 15. So how much time you get this? 40. Now 1 plus, this is already fixed to 0. Na? 1 plus 0 will give you 1 in the output. Okay. But this fellow requires another 10. So what time you will get? 15 nanoseconds. So if analyze only one figure, you got this much. If analyze 3 figures in this, just to see how confusing it is. So don't be lazy, always analyze in the clear way. So any method you do the analysis, your answer will be same. Okay. So it depends on your convenience. Whichever you feel convenient, apply that. Okay. Unless you mess up in between, both the methods are okay. If you stuck at some point, then yes, right, AD. Worst case delay is same man, n minus 1 into TC plus maximum of TS and TC. Here TS is 40. TC is this part 20, 35, 45. Simple rule. Direct formula. Worst case is same formula every time. You want, I will write it. Yeah, you can calculate that. Please listen. I will write it. In the above case, if okay, worst case delay for any input, not for this input. For this input, worst case or best case, whatever may be, delay is same. For any input, it is n minus 1 times TC plus maximum of, you are getting less means you are wrong. N is how much? 4 minus 1. What is the TC here? TC is how much? 20, 35 and 10, 45. Plus maximum of 40 and 45. Because some requires 40 nanoseconds. So it is 90, 90, 180 nanoseconds. Someone claims that they got less. Who is that? People, if you want, you can attach your answer. I will cross check if you want. Okay? Where you are wrong, I can point. Done. This is if required. So let's do one more question of the similar model that I will give you. Now, do you have any doubt in marks, etc.? Okay, 1 minute. So for the sum part of full adder, even though the output changes in between, it says y Listen, Manjunath. What is the question? Output of the ripple carry adder will be stable. Stable means 0, 1, 00. At this point you are stable, or at this point? At first point you are stable, or at the second point you are stable. That's what I did. Okay. When in between it is changing, it's not stable. Huh? Stable means further it should not change. That's why I show that. So if you blindly say, if means you means not you, generally I'm saying, if people will do the same problem blindly saying that it is 0 initially, finally also 0, answer they will get in this question, not every question. Because if this hazard occurs not 45 seconds, suppose it occurs at 60 nanoseconds, then 50 and 60 you consider, what is the answer in that case? 60 will be your answer. Yes or no? So we should be careful about it. So if you apply any method, that method should be universal. That is our intention. So let's do one more question. I will give you. Right. So shall we conduct some kind of quiz? I mean, let's see how many of you will answer. Now I will keep on giving you the questions. How many will try to answer? I will start after 1-2 minutes. So meanwhile you can try. So sum is equal T sum is 25 nanoseconds and T carry equal to 15 nanoseconds. So I will give you the options. So if you are ready, I will start the poll. Just take your time, try it first. If it is not visible, I will zoom if you want. Just read the question. Read it. If you are ready, I will start the poll. Okay, take your time, no problem. It's a similar model, but not that difficult. It is easy. Are you ready, everybody? Guys, ready. Very good. Right, start. Your poll started. Read it. Amitabh, Ruchita, Very good. RK Singh, Jafra, Anupama, Bharati, Abhineet, Sadbhavana, Rahul, and Himas. Very good. So most of you have opted this wrong answer. Okay, so let's do it. What's the statement? It's triple 1 0. Second one is all ones. With carry input 0. So what is your T sum? 25 nanoseconds, and T carry 15 nanoseconds. So let's read the question again. You have a 4-bit triple carry adder is designed with 4 full. Yeah, some issues there. 1 minute. Maybe I need to log out from mobile. Yeah, fine. Okay, a triple carry adder is designed with 4 full adders. In each full adder, sum requires 25 nanoseconds, carry requires 15 nanoseconds. Initially, all inputs are reset. Okay, so initially assume everything is at 0. So final result is taken from this one, carry and whatever you have. This A3, A2, A1, A0 and B3, B2. Before B3, B2, B1 is this one, carry 0. Minimum amount of time required to stabilize, same as previous question. So tell me here, 1, this is 0, 1 plus 1, what is the answer? So firstly, this part requires how much according to you? 25 nanoseconds. First, I will show you where you commit the mistake. Then 1 plus 1 is sum 0, carry 1. Okay, so 0 plus 1, 1. Okay, he has not given internal circuit, you need not worry about it. Okay, so 1 plus 1, sum 0, carry 1. Then 1 plus 1, sum 0. Sorry, 1 plus 1 plus 1, sum 1, carry 1. So this part requires how much time? You are applying this carry at 15. Okay, this will come at 15 plus 25, 40. And if you apply this at 15, this carry will come at what? 30. And now 1 plus 1 plus 1 is sum 1, carry 1. So 30 plus 25, this is 55. And this will be 45. You might have done like this, some people at least. Yes or no? This is wrong analysis. This is wrong analysis. Where we are wrong, sir? Yes, I will tell you. Just listen here. Here you are adding, okay, 1 plus 1, sum 0, carry is 1. At what time you are taking the carry? At what time you are taking the carry? 1 minute. At t equal to 15, you are taking the carry. Then you will get this, whatever you are sum. Okay. For this carry, you are taking 30. Nah, this is wrong. Why? By earlier, मेरा पास 1 1 है. Here also. 1 1 is sum 0, carry 1. And triple 1, what is that? Sum 0, carry 1. I am refreshing. Some internet issue is there, don't worry. I hope it is fine now. Is it fine? Please comment once. Waiting for something is there. Okay. Some server issue is there. Okay. So you understand the logic. Here 1 plus 1 will give you sum 0, carry 1. Okay, even this carry is not given also. Already this 1 1 will be added. Please understand this. Already this 1 1 will be added and sum may be 0, but the carry is already present. So this carry will not originally come at 30. This carry will come at what time? Everybody comment now. 15. This carry will come at 15. This carry will also come at 15 only, not 30. That is the point. I don't know, somewhere it is pausing. Is it clear, everybody, what I am saying? Then I will do the problem again. So now, listen. 1, 1, 1. What is that? 0. And again, take all ones. Now, this will come. This will become 1 at what time? Time t equal to 25 nanoseconds. This is 0 only. When it is 0, don't worry. Sum 0, carry will be 1. At what time? Time t equal to 15 nanoseconds. At the same time, this 1 will also, by the time you give 1, already this 1 will be added. Initially, how much it is? It is 0 at 25 nanoseconds, and this will be 1. Because they don't know, next you are giving something new. This will be coming at 15. And this will be coming at 20. Okay, same here also. By the time before you give this, this 1 will be added, and you will be getting 0, and this part will be equal to 1. At what time you have added this? Now you will get it at 15 itself. You understand here, please, properly. Forget about this blue part. First, these numbers will be added now. Before giving carry, 0 plus 1 will give you 1. 1 plus 1 will give you sum 0, carry 1. But before giving this itself, this 1 will be added, and sum and carry will be ready. Similarly, before giving this carry itself, these two will be added, and sum and carry will be ready by 15. Carry will be ready by 15 nanoseconds. Sum may come late. Don't worry about it. Is this point clear to everybody? Someone, Udit, you asked me, is it clear? Please tell. Okay, fine. Then your problem is very easy now. So now see here, at 15 you have applied this one now. So 1 plus 1 plus 1 will give you sum as 1. Okay, that will happen at 40 nanoseconds. So already this one is applied at 15 now. At 15 plus 25, 40 nanoseconds, it will also become sum. And this one at 15 you apply, at 30 also you may replace this one with another one which is of no use for us. So finally you observe everything. At what time you are getting the answer? 40 nanoseconds. Little tricky. Okay, if you are able to understand the logic, it is very easy. Because adder will not wait for new input, it will always do its job. Shall we move to the next question? Green part I want to repeat. Aditya, please see. See here. Listen, Aditya. Firstly, at 15 nanosecond, you applied this. At 15 nanoseconds, you applied this. All ones. You comment at 15. If you apply 3 ones, when will you get the sum? And when will you get the sum? Comment, Aditya. Sum requires 25, man. You applied it at 15. 15 plus 25. Only Aditya. 15 plus 25, 40. Okay. Similarly, you applied this at 15. What is that? 1. All ones will give you sum at 40 itself. But because of these 3 ones, another one will come. But that will come at what time? 30. But no use, because already it is at 1. You give 1. It will not change your system. I'm repeating this. At 15, you applied all of them. At 40, you get this. Similarly, at 15, all of them are already ones. It will give 40 by this one. But what I am saying is, you understand? These three ones will give you some one, carry one. That will change at 15 plus 50, 30. But already it is at 1 na, it is of no use for us. Is it clear, Aditya? Already at 15 nanoseconds, 3 ones will give me 1 at the 40. Now at 30 nanoseconds, you give another 1. Again, it will give you same answer only. So everybody clear? I will move to the next question. So where is the diagram, Abhinit? If you have diagram, you can do it, but he has given only block diagram. You don't know the internal circuit here. Right. So now I will give you the next question, which is my handwritten. I'm not able to get it typed because at the last minute I gave him other work of DPP also. So I just with my handwriting. I hope it is visible. So now my own made questions are coming. Get ready. I will start the poll. Option A is 0, option B 1, option C C2 equal to C out, option D none. Okay, so what is your A? I wait, light with better color. A is equal to 1,000,000. B is equal to 1,001. Okay, you know what this circuit is already. So what is the question? If the BCD adder is implemented is shown in the figure, A is 1,000,000, B is 1,001, determine C2. Determine C2. I will start the poll. Get ready. Are you ready? Okay, get ready, get ready. So my questions are not difficult but logical. So are you ready? It's a BCD adder. Yeah. So let's start the poll. Wow, nice. Rishikesh, Suraj, Kunal, Asif, Swapnil, Deep, Arun, Matthews. Shivam, Sagar. So today now Kumari is on top by doing 2 by 2, all the 2 questions correctly. Amitabh, 1 by 2. What happened here? Your leaderboard is gone. Okay. What is the right answer? Comment now. What is the right answer? Option A, 0. This is your trap. Okay, be careful. That's why you should understand the concept of BCD adder properly. Okay, originally what I told, this C out will be taken as your carry. You saw BCD result is equal to C out B3, B2, B1, B0. I already told that. Okay, earlier also. But now what I asked is not the same thing. What I asked is this part. What is C2? I asked. So first you do this addition. First adder 1, 0, 0, 1 plus 1, sum 0, carry 1. Okay, then because carry equal to 1, this is C1, please understand. This carry equal to 1, this OR gate carry equal to 1, OR gate will give you 1 here, that it will add 6. It will add 6. So 1, what is this? Sum 0, 1, 0. Any carry is coming originally? This C2 will be equal to 0 only. This addition will not give you any carry because you are adding these 4 to these 4. Okay, that is the result you got it. That is 0, 0, 0, 1. When this carry equal to 1, this will give you 1. That will give you 0, 0, 0, 1 will be added to 0, 1, 1, 0. Okay, so if these are added, you will get the 7 in whatever may be 0, 1, 0, 0. Na? You may get 7 in the result. That is okay. Carry will not be generated here. That's why we are taking this carry. I told you this in the concept clearly already. You remember or not? Yes or no? Day before yesterday. I told already when you add 6, A plus B, the result only, not A or B. A or B are always less than 9 only because they are BCD inputs. Result is greater than 9 or not. How to check? Sum greater than 9 or carry equal to 1. We should check sum greater than 9 or carry equal to 1. Then I told result is greater than 9. Already I told all these things. I hope you remember. Then add 6. I'm not saying C2 equal to C out. Who said C2 equal to C out? Your C out is this. C2 and C out are not same. What happened, Chaitanya? We discussed this in the class already. We don't take this carry, we take the OR gate as the carry. C2 and C out are not same. Yes or no? We discussed that in the class already. C2 is not equal to C out. I already told add 6. Okay, and what is the statement I told? When add 6, take final C out equal to 1. All those things I already told. So this by me only, not from previous papers. So let's add one more question made by me. I made around 170 logical questions like this. I am giving it for typing. Okay, once that typing part is done, I will share to you freely. Don't worry. Let me check which question it is. This question is not trap. This is simple conceptual question. Nothing difficult in this. It's a easy question. If you know the concept properly, traps will come definitely. So if you know the concept, you can answer. Read the question. Okay. Yes, so this is like A1, A0. This is like B1, B0. Just say AB is one 2-bit number, B1 B0 is another 2-bit number. Yesterday we discussed this in the class already. Are you ready? But I forgot the answer. No problem. Okay, try. One minute. I will also check. You just keep trying. Yeah, no problem. I am also checking the answer. Okay, if you are ready, I will start. Okay, start the poll. I'm not giving the answer because I'm not sure of the exact value. Yes, yes. Let's see. So different people got different answer. Yes, I gave this as homework. Yeah. So when will you get A less than B in a 2-bit comparator? Yesterday class we discussed this already. Sigma M of what are they? A less than B. 1 0 0 1 0 0 0 1 1 1 2 3 6 7 11. Okay. Just make a K-map, your job is done. Not A less than B. Here X less than B. Na? X less than Y. See, in this simple question also people are doing wrong. X is AB. So first you take AB followed by CD. So 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1. So 1 2 3 6 7 8 9 10 11. Done. Your job is. Why to write table, man? Just calculate in the mind. How I written is like in the mind 0 0 0 1. Okay, I remember this and 0 is less than 1 like that. Don't write the whole table. That will kill your time. You know how to count the numbers sufficient. Right. Oh yeah, job. So what is your function? F equal to this part is, what is this? A bar C. Next, A bar B bar D plus B bar CD. If there is available in the option A bar C, A bar B bar D, and B bar CD. Let me change it. Oh, it is there. I'm sorry. Okay, fine. So it's a simple question. Already I told yesterday you were there in the class, Shaheen. Yesterday you were there or not? Yeah. What is 1 in your mind? You should check. 0 is less than 1. What is 2? 0 is less than 2. 3, 0 less than 3. Okay, first time it will come 3, second time it will come 2, that next time it will come only 1 is one shortcut you should remember. For 0, 0, 3 times it will come. For 0, 1, it will come only one time. For 1, 0, it will come 2 times. For 0, 1, it is only for 0, 0. Na? A less than B, na? I'm sorry. A less than B will come here. It should be for 1, 0, for 1, 1. 2 times it will come. For 1, 0, it will come. A less than B will come for 0, 0, and yeah, only one time. That's all. For 1, 1, it will not come any time. Like that, you can remember. For 0, 0, 3 times. For 0, 1, 2 times. For 1, 0, 1. Any method in your own mind, you calculate any way. So it's 2 questions. Okay, this is one question. Next question also part of this. So read the question carefully. I will give one more question. Just wait. Hmm. Okay, 1 minute, please. I will load 2, 3 questions. Then you can do together. Because the order is little different. The question I want to discuss is not coming. Otherwise, first to do this question, then we'll see the other question also. Just read the question. I want to give you 2 good questions that I forgot to download maybe. In a carry look ahead adder, if XOR gate is having a propagation delay of 2 nanoseconds, AND gate or gates are having a propagation delay of 1 nanoseconds, with minimum delay each, what is the minimum delay required for sum and carry respectively in nanoseconds? Okay, so here add the line in a 4-bit. I will start the code. Don't worry, just wait. In a 4-bit carry look ahead adder, if sum requires, like this is the question, okay? What is the delay required for the carry and the sum? Are you ready? Shall I start the poll? Meanwhile, I will. Ready? Out of the 3 questions of your today's quiz participation, no one answered 3 by 3. Yeah. What happened? Amitabh, why you are answering earlier also you answered, still it is showing 1 by 3, something wrong with the app. Okay, RK Singh, Kronal, Kumari, Chaitanya, Nishita, Abhineet, Harshat, Amitabh, Rushikesh and Manjunath are the top 10 who have answered right in the today's. So what is the right answer? Here is 3 by 5, which we have done just fast. Okay, question of yesterday class. You remember or not? If you don't remember, I already told that. Okay, here you can take OR gate and AND gate. I made this already yesterday class. AND gate, OR gate, and this you. So 3 and 2, which one will come late means 3. 3 plus another 2. It will be 5 nanoseconds. Simple. Already we have done this question yesterday. Still see how many people have given wrong answer. Do you remember or not? Same question. I just modified a little and I gave it. Okay. Examiner gave 6, so that's why some people might opted 6. Okay, I have proved it already by 5 also it is possible. What's happening? No comments are coming. Yeah, let me download one more question from the mail. I kept it. So kindly adjust with my writing in this because I don't get the time to type. Okay. So 2 questions I am giving you here. These questions only we made it. Okay. So that if you do these questions, your concepts will get more stronger. Right. So do this question. 2 questions are there. Let us take this as first question and this as second question. Statement of other linked questions. Okay, if a 3-bit carry look ahead adder, it is to be implemented using 2 input gates, AND gate, OR gate, XOR gate. What are the all gates are available, but restriction is 2 input gates. If each gate is having a propagation delay of TPD, all gates are available here, not like previous question. Every gate is available. Determine the minimum number of NAND gates. Sorry, minimum number of AND gates, OR gates required in the carry generator circuit. If the design is made with the least possible propagation delay. So get ready guys, I will start the poll. You remember the last lecture, carry look ahead adder we have discussed, formulas I have given. I will wait, don't worry Asif. Take your time. Ready? So let's start. So last formula earlier I told n and n into n plus 1 by 2. Forget about that formula here. Very good. Some people gave right answers. I'm happy. Chaitanya, Harshavardhan, Abhinay, Asif, RK Singh, Krunal, Kumari, Nishita, Avineet, and Aditya. Right answers. So let us see. In this only, okay. Okay, no problem. In this only, one more question is there. After doing these two, I will explain both. Don't worry. So see the second part. Each is 1 TPD. Then what is the delay for sum and carry? Yeah, linked. Same question, extension. Extension. Determine the propagation delay for sum and propagation delay for carry. I'll give you time. So let's start the poll. You can try your luck. So if you don't have any further doubts, I will end the class today little early. Sometimes I will little early I can end, and sometimes I will take more time also. Depends on the topic. So tomorrow be ready if I take 2.5 hours also. Good. So out of by the end, Chaitanya three questions, Krunal 3 questions, Asif 3, and Harsha, Mohan, Abhinay, RK, Ruchita, Deep, Kumari. Yeah, not one doubt. You ask n doubts, I will answer. So Krishna, just wait. We'll talk. Don't worry. I didn't see. It is same as previous question. Yeah, your n is 3 bit. It is same. Okay, Krishna, first ask your doubt, then I will explain. Okay, n can be anything. You ask n as per your wish. In not in this question, then wait. End of the class we discuss. Don't worry. So let me upload the answer to save your energy. Last lecture I discussed this, if you remember. From our lecture notes only. Okay. So you remember this or not? What is this? CLA, carry, look ahead, adder. Last lecture we discussed this. Okay. Here one way is if all gates are with n number of inputs, no restrictions, it is a TG, 2TG, and whatever 3TG and 4TG. This is fixed for any number of inputs. It doesn't change. I told already this point. Suppose here One concept you should understand here is, here one AND gate, here one AND gate and two AND gates, and next is 1 2 3 and so on, it is increasing. One more pattern you should observe here. It is 2 input, it is also 2 input. What about this one, sir? 3 input. Here 2 input, 3 input, uh, 3 input and 4 input. So if I keep on doing this, then what happens? Next case, it will be, delay will not increase in this case. Next case, suppose if I make, for example, see here, for n equal to 3, first case only 2 input, second case 2 input and 3 input, third case it will be 2 input, 3 input, 4 input gates are required. I am saying about only AND gate. We'll speak about OR gate later. Okay. Is this okay? Is this okay? Yes or no? Tell me, yaar. Next. Okay. Similarly, I want to generalize the things because you cannot remember n number of things now. So let me generalize. Okay. So if you take n equal to 4, how many AND gates are required? Means first stage 1 2 input, second case 1 2 input, 1 3 input, third case 1 2 input, 1 3 input, 1 4 input, and so on. The story continues. 2 input, 3 input, 4 input, and 5 input. Okay. Who will decide the delay? Delay decided by this fellow. Delay decided by last one. Okay, that will take it later. Don't worry. I want to give you the concept. Please understand that. Let me take a screenshot so that I will use it in the next slide, because we can save some time and my energy also. Okay, right. Is it clear? Now, please listen. One more important challenge. If you want n input AND gate, okay, how many 2 input AND gates are required? Can you know? Do you know this? Have you ever tried this? Very good, very good. N minus 1. Very good, very good. So, for example, if you have first case, you want 3 input AND gate, you can make AB into C. If you want 4 input AND gate, you can make AB, sorry, into C into D. But you are an intelligent student, then you implement not like this. Why, sir? Here 3 delays, here 2 delays. You understand? Your brain is having importance here. Both are correct, sir. But which one is best, sir? The second one. 2 delays may come, will be done. Okay. So you understand 3 input AND gate requires 2. How many are required? 2. Any method you implement, how many are required? 1, 2, 3, 1, 2, 3. So n input AND gate requires how many? 2 input, n minus. These concepts I want to give you. Okay, don't worry about that problem. Once these concepts are in your mind, that problem can be done in 1-2 minutes itself. So this concept, this basic is clear for you? Shall I move? Okay. Now you answer. N equal to 2 input, 1 gate is required. For this, 1 plus 2 gates. 1. For this, how many gates are required? 1 plus 2. For this, how many required? 1 plus, for this 2, for this 3. So how many AND gates are required? 1 plus 3 plus 6. That is 10. Number of AND gates equal to 10. Okay. Now come back. What about OR gates, sir? Here OR gate is 2 input, here OR gate is 3 input, here OR gate is 4 input, and so on. The story continues. Okay. What about OR gates? If n equal to 3, first case, how many? OR gate is how? OR gates are 1 only, but here 2 input, here 3 input, here 4. 1, 2 input. Next. Okay, you have 2 input, 3 input, 4 input, and how much? 5 input. You can generalize the things now. Is it okay? So here, please tell me, same rule for OR gate also. OR gate also. If you have A, B, and C, what is the answer? A plus B plus C. Same. What is that? N input OR requires n minus 1, 2 input OR. So tell me the answer here. Only 1. Here 3 input means 2. Here 3 input means 3. So the answer is 1 plus 2 plus 3. What is the answer? 6. So if you want to do the job with 6, okay, so what we call 2 input gates only. Here, how many gates are required? 6. So what is the answer here? AND comma OR is equal to 10 comma 6. Okay, when n equal to 3 bit, number of 2 input AND gates and OR gates in the carry lookup adder is direct formula. Now you can derive y6 are 1 plus 1 plus 2 plus 1 plus 2 plus 3. Here what is the answer? 1 plus 2 plus 3. Now I am deriving for n bit. For n bit, what is the answer? 1 plus 1 plus 2, 1 plus 2 plus 3 plus, and so on. 1 plus 2 plus, and so on. This series will continue, and that is for AND gate. For OR gate, what is the answer? 1 plus 2 plus 3 plus, and so on. This is for carry lookup adder using 2 input gates. This you cannot get in the textbooks. I am sure about it. Any book. Examiner want to trouble you, he will definitely do this. Okay. So it's our own question. What is the answer? Where we are? Yeah, question me it is specified now. Aditya, see. Okay. So I don't want to give you blind formulas. So concept is important every time. Then you need not mug up the things. While generating G, what is G? No, in the question, please see, statement is like this. Implemented, okay, in the question, it is only in carry generator circuit, not outside the circuit. He asked only for generator circuit. So generator circuit is only this part. They are outside. All slides I will give you. Don't worry, Ashish. This is the question slide. This is the original figure. That's all. Okay, Ashish. Okay, fine. So what is the next question? No, I made not all questions single day. Na? I take some 1 hour whenever I'm free. Some 10 questions like that I made. Not all questions in a single day. Your brain will not work properly. So now, see here. Thank you, Abnit. So after doing this implementation, how much delay is required? It's the same figure only. Is it visible or can I zoom? Here. Can I zoom? Okay. So please listen. After doing this question, calculate the delay. What is the delay? If you don't go, keep on implementing, this is 1 delay, 2 delays, 3 delays, 4 delays. What is here? 1. This is 1 delay. Okay, this is always this is 2 input only. Never worry about it. Then 2, 3 delays, 4 delays, 5 delays. Here please understand. If you implement the same question instead of this as your circuit, if you implement by this, it is not least delay. If you give output of 1 gate, examiner sometimes may say like that. Output of 1 gate is given as input to the next gate in the serially. Okay, it is different. This is different. Okay. For the least delay, we should use this one, not this one. Okay, if examiner specifically say, you should take that. We don't say generally, you don't ask, but I'm saying, okay. I gave that concept already. So for the carry, you require 5 delays, and for the sum, you require 6 delays. So go back. So for the sum, you require 6. For carry, you require 5. So let's try to generalize this also. So what you can say is your delay depends on last stage only. Will you accept? Because this is taking more time compared to any other. Delay depends on last stage only because it is taking more time compared to any other. So that you concentrate, you can say the delay in this case. So for that, one minute. So in the n bit, first I will tell for 3 bit, then I will generalize. It will be good. In the 3 bit, carry look at last stage. Okay, you will have 1 2 input AND gate, 3 input AND gate, and 4 input AND gate. Already we told this. And what about OR gate? OR gate will be 3 input. 3 input or 4 input? 4 input. Then I will generalize also if you want. Okay, don't worry. So here 4 input OR gate requires n minus 1 2 input. So n minus 1 delays. Okay, already this requires OR gate requires how much? N minus 1 delays are required. But you observe OR gate output is coming from some other locations. Here, from here to here, from here to here. Okay, so OR gate inputs are not directly available, so they are coming from different locations. So you should compulsory 1 minute. One minute, please. I need to give you extra concept here. Will you try to derive or shall I derive it? Can I give it as a homework for you or shall I try it? If you want, I can derive it like this. I will give you the procedure. I don't want to waste much time here. For example, you want n input AND gate. If n equal to 4, how many delays? 2 gate delays. If n equal to 3, here also 2 gate delays. Similarly, n equal to 5, A, B, C, D, E. Okay, here also 3 gate delays. And n equal to 6 also can be done in 3 gates. Okay, so for n equal to 3, 4, 5, 6, delays are same. You can understand that. So if you have n input, round off n by 2. Is it okay? For 9 input AND gate using 2 input, what is the delay? 9 by 2, you round off. Round off is like this. It is 5. Integer value, next integer. For 10 input also, using 2 input, what is the delay? It is 10 by 2. Is 5. Okay. But if you implement serially, that like this, gate output to another gate output like this, okay, then it will be 8 delays. Okay, delay increases here. This is not best. This is not best. This is the optimum way to do it. So now come back. So for this part, you require 2 delay. Okay, so that is up to this, you require 2 delay. And again, for your OR gates, you require 2 more. Total 4 delays in carry generator circuit only. Okay, for carry, total carry, I'm generalizing. Please understand the concept. Total carry, it is 4 plus 1, which is 5. For total sum, it is 5 plus 1, which is 6. I will explain. Don't worry. Just go back. I'm saying this internal part is requiring 4 delays. 1, 2, 3, 4. Then one extra is required for this. So 5 delays for carry and another for this 6 delays for sum. Okay, 5 plus 6, total 6 delays. That is what I did. Here 4 input by 2 you do half. Delay is n by 2 is the formula. Okay, it is n is number of inputs, 4 by 2. Here everything we derived and proved here. Please understand that. Is it clear, everybody? If you have doubt, ask me. These lines you remember, okay? If you take here 3 input, okay, if you take here n, It is same, but you have only two input gates. Now delay may slightly increase, not more. Okay, Aditya, in general, yes, you as you said, in original practice, generally you will be having n input. When you have more number of inputs, is then only more advantage of the CLA. Definitely that is true. If you have more number of inputs, then only the original advantage will be there for CLA. But if you are limited with the number of inputs in the gate, then before design, you can compare. If you do like this, how much delay is there? Okay, if you directly do it, how much delay is there? Which one is better? Then you can, when you are designing, you can compare these things. Is it clear what I'm saying, Aditya? Okay, more delay of 6 means you take 2. Yes, that's what I'm saying now, Aditya. You take a direct ripple carry adder and this circuit. If it is giving you more delay, then we go for ripple only, provided you are not having n number of input gate. If you are restricted to use only 2 input gate, I don't have extra circuitry, then you should decide that. This will be helpful to decide whether to go for ripple or whether to go for carry loop ended. Is it clear, Aditya? So guys, that's all for today. Any kind of doubts you can ask. You don't get n by 2. Swapnil, see here, simple concept. You want to implement a 4 input gate, you can implement like this. A 3 input gate, you can implement like this. Please listen. Yes, Swapnil. In both the cases, what is the delay? 2 delays only. Swapnil, clear? Similarly, if you have a 5 input gate, you want to make 5 input, 4 input, and another AND gate will give you 5. For 6 input, this is the way to implement. Now, please listen. Please listen. Now you understand. Yes, Asif, then you should compare both. Then here also 3, here also 3. From this, I can conclude like this. If you want 3 input gate, 3 by 2, 2 delays. If you want 6 input gate, delay is 6 by 2, 3. 5 by 2, 2.5 delays, you are taking it as 3. You understand that? Round off, then you will get the answer. So that's all for today. Tomorrow we continue with the mux, so please don't miss it. We'll just do more problems. I will provide DPP also. When it is not changing in between, Krishna, when it is not changing in between, we are not considering that. That is the simple rule. Okay, let me go to that slide. Okay, Krishna, just see this figure. In the very first question of triple carry adder FA3 analysis of the logic circuit, the second gate is having input as Z3 equal to 1 and the input 1. You understand, I have considered here and I gave 20 nanoseconds. When you get this one, I considered this. Where I neglected, can you show me in which gate I have neglected? You take this as 1, 2, 3, 4. Which gate I neglected? Can you tell me? I have not neglected. Krishna. Why not considered in second AND gate? See, in the second AND gate also, your inputs are applied at what time? This is applied at 20, but by this time other input is 0. 1 into 0 is how much, man? For the second AND gate, you see, firstly, this at 20, 1 is applied, but by this time this is 0 only. Firstly, initially, listen first. At t equal to 20, this is 1, this is 0. Listen first. I will come to your doubt. First, listen carefully. Initially, this is 1, this is 0. At what time? T equal to 20 nanoseconds. At 20 nanoseconds, 1 into 0 will give you 0 only. 0 changing into 0, you don't consider. But at 25, your friend Z3 came. Once Z3 comes, we have considered this. Z3 becomes 1, both are 1. It will give 1. That's why 25 plus not. What is the delay of this 15? Another 15. 25 plus 50, 40 is taken. Now ask me what is your doubt. You are getting two inputs parallelly, not serially. Please understand, Krishna. This is coming 20. Suppose it came at 2 o'clock. This came at 3 o'clock. What is the time when both inputs are ready? Means 3 o'clock, not 2 plus 3, 5. This fellow came at 2 o'clock morning. This fellow came at 3 o'clock. So when both are ready means you can say from 2 it is waiting. This fellow came at 3. Yes, that's all. Not 5 now. This fellow came at 2, this fellow came at 3. Will you start the job at 5? No, same. This fellow came at 20, this fellow came at 25. We take 25. Very good. So next, Rahul, some question is added. Rahul, active high that we discussed in the logic family. If you want, I can answer. This we discussed in the logic family topic. Okay, I discussed this point will act as a wired AND gate. Okay, that is AND operation of these two. Simple, you try that. And this point also acts as an AND operation. So this we discussed in the class itself. You get X bar into X, because this is X X bar into something. This is always 0. So if it is 0, when this part is 1, you will get output 1. So this part can be 1 for 8 combinations that we will answer. Here wired AND operation. He has given in the statement. So this point will act as an AND gate. That generally I discussed in the logic families topic. Okay, so that's all for today. So we'll end the class. We'll meet tomorrow. I will make logical but not difficult. You understand it in the class. See, my motto is in the class, you should feel difficulty. In the exam, you should feel happy. Okay, so thank you very much. Good night. We'll meet tomorrow. Good night. Good night. Thank you.